Question number 8 of the worksheet on forces in motion. The diagram shows the velocity time graph for the motion of a small stone which falls vertically from rest at a point A above the surface of the liquid in the container. The downward velocity of the stone t seconds after leaving A is v. Okay, so this is represented by these lines. So we can see that at time 0, the speed was 0 and or the velocity, and then the velocity starts to increase and it becomes 7 meters per second at point 7. And this is where it hits the surface of the liquid. So it started with u is equals to 0. As it hits the surface of the liquid, the speed is 7. And then, since it goes into the liquid, the speed begins to decrease, and the final speed is 5 then. This would be 5. Let's call it V again, 5. Okay. So the stone hits the surface of the liquid with a velocity of 7 at time 0.7. It reaches the bottom of the container with a velocity of 5 at time 1.2. Find the height of A above the surface of the liquid. So we need this height, and this is the distance traveled by the object, by the stone, and this in the graph is represented by this area. So either you could use the formula for area under the graph. That would be half times base times height, which gives 2.45 meters. Or you could use equations of motion. U is 0, V is 7, and the downward acceleration in free fall is plus 10 meters per second square. So you can use equation of motion and find S. You could use S is equals to ut plus half at square. Now that would also work because we know time is 0.7 as well. So you can use any equation of motion that can give you the S, and you would get the same value. Okay, moving on to part B, the depth of the liquid in the container. So now we need this height. That could be found by using distance formula on this shape. So that would be area of a trapezium, which is half times height. Height is the distance between the parallel sides. These two are the parallel sides, and the height would be 1.2 minus 0.7, which is 0.5. So half times height times sum of parallel side. This is one of the parallel sides, 5, and this is the other parallel side, 7, which gives us 3 meters. Okay. You could again use equations of motion here as well. You know, u is 7. Now this would become u for this journey. U is 7, v is 5, and time is from here to here 0.5 seconds. So u7, v5, time 0.5, and you can use these to find distance. The formula could be S is equals to half u plus v times t, and this should also give you 3 meters. Part 2 says find the acceleration of the stone while the stone is moving in the liquid. Okay, so now you need the value of acceleration here. Again, you could use equations of motion because now you have S as well, U, V, and T as well. So you have so many values that you could use in any one of the equations of motion. We have U, 7, we have V, 5, we found S from the previous part, 3 meters, and we also know the time, 0.5 between this part of the journey, and we need to find the value of A. So either use equations of motion, we could use V is equals to U plus AT. So 5 is equals to 7 plus A times 0.5. This gives minus 4. Acceleration would be minus 4. So deceleration is just the magnitude, meters per second square, 4 meters per second square. Okay. Or you could use the formula rise over run. You can find the gradient of this line. That would also give you the deceleration or the acceleration. Okay. So we can say acceleration would be rise. Rise here is 2 and run here is 0.5. So we'll get the same answer 4. And remember, since it's a falling line, so the gradient would be negative. So acceleration is -4, but deceleration would be 4 meters per second square. Okay. Last part says that given the resistance to the motion of the stone while it is moving in the liquid has a magnitude of 0.4 newtons. So let's draw the system. So here's a stone moving inside the liquid downwards, and there's a resistance to the motion. So that would be pointing upwards, 0.7 newtons. And the downward force is going to be its weight, which is equals to mg. Mass of the stone is 0. Uh, do we have the mass of the stone anywhere given in the question? Oh no, we have to find the mass of the stone. So mg is the weight, that would be 10m because the gravitational acceleration is 10. Okay, so we're going to use the formula forward force minus backward force is equals to m, and acceleration was -4 in this part of the journey under the water. Okay, now we rearrange. We have 10m plus 4m is equals to 0.7. So 14m is equals to 0.7, and 0.7 over 14 would give us 0.0, 0.5 kg. 0.05 kg should be the answer.